Hey there, my fellow intellectuals. How are you doing tonight? Tonight, I want to do something a little bit differently, and that is try and condense my 4-year physics bachelor's degree in one video. I know that sounds really hard, but I'm going to try and do it. For those of you who might be new and may not know, I have a bachelor's degree in physics from the University of California at Merced. It's the newest University of California, and if you look at the actual diploma on the inside here, you might be able to see, if the camera will focus, that I have a degree in physics, and that if you look at the very bottom here underneath the insignia, it says graduation highest honors. And this is easily probably one of the most proudest achievements I've ever been able to accomplish in my entire life. I'm very grateful for the opportunity I had at UC Merced in pursuing this major in the subject that I love the most. But the main reason why I wanted to make this video is that I wanted to be able to give some insight as to what goes in a physics degree, because I think there's a lot of misconception, because I think when a lot of people who don't do physics think about physics, they're typically thinking about like Albert Einstein, Stephen Hawking, black holes, dark matter, Higgs bosons, all those sort of buzzwords. But these buzzwords don't really give a complete picture of what goes in a physics degree. And I thought it might be cool if I just pull up my transcript here and actually just show you all the different classes that I took and sort of show you my own career path, because I didn't just always do physics from the onset when I was in college. So if we just start from the top here in my transcript, we can see Bachelor of Science, degree was awarded back in May of 2017, so that's more than 3 years ago now as of this video. We can see that my major was physics and applied mathematics, as I mentioned before, and that I came in with some credit in chemistry, math, and writing due to the advanced placement system in the United States. So I was able to skip the first classes in these subjects. So let's go ahead and start at fall 2013, which was my freshman fall semester. So from the onset, we can see that I wasn't always a physics major. I was actually a mechanical engineering major to start, and I was a mechanical engineering major for the first 3 semesters, actually. But the reason why I switched out of mechanical engineering, well, maybe before I talk about why I switched, I should probably say why I started in it in the first place. I started in it because I thought that engineers used math and physics, and that's true, that they do. And they use that to solve real-world problems, which is also true. That's what they do. But I just really wasn't so big on the sort of building and design aspect of engineering, which are big components of being an engineer. And so I realized that I was more into sort of solving equations, solving really hard theoretical problems, and just sort of learning more about the universe itself, as opposed to maybe solving specific real-world problems. And so it took me a while to switch out of engineering, but it does change eventually. So if we start in the first class here of fall 2013, it was Calculus 2. For those of you who may not be aware, Calculus 2 is where you learn about the concepts of integration, you learn about different integrating techniques, you learn about series and sequences, and this is all sort of a continuation of Calculus 1, which I learned in high school, and I was able to pass the high school exam. And this class was fun because I had a really funny and lighthearted teacher who was really good in the course. And I remember I think I got 100 on one of the midterms in this course. So that was a pretty solid course to be in. I really liked it, and this is why Calculus 2 is probably still my favorite branch of calculus to this very day. So moving on to Philosophy 1 here, we have Introduction to Philosophy. This class was very chill and laid back. This was sort of like some sort of, I think, humanities requirement I had to take. And the philosophy course was simply just going to lecture, listening to the lecturer talk about different philosophers like Descartes, Aristotle. Who else did we talk about? I think we talked about Nietzsche a little bit. It was very sort of brief segments on different kinds of philosophers, and it was really easy. It was like you go to lecture, you listen to him talk for like an hour, and if you do the readings that he assigned, you'd automatically just get in the class, because all the tests were the entire grade. So I think there were like 3 tests. And if you went to lecture, you would know everything you would need to know on the test. So very easy. Next up on the list is Physics 1. So Physics 1 is just introductory mechanics. That is sort of learning about Newton's laws and applying them in different scenarios, like learning about like you're pushing boxes on frictionless surfaces, or you're pulling stuff up on inclined planes, learning about concepts of kinetic energy, potential energy, work energy theorem, all these sort of things. I don't really want to get too technical about it, but that's essentially what you learn in Physics 1. Now, I'd actually taken physics, this kind of physics in high school 2 times. So I took honors physics in my junior year in high school, and I took AP Physics my senior year in high school. But I did not pass the AP Physics exam, as you may have noticed above in the AP credit section. Now, this is sort of like a story where I think I got a 2 on the AP Physics exam, and I was really kind of down about it because I really liked physics, and I thought like I let myself down. I let down my high school physics teacher. But, in the end, it's like you don't really need to pass the AP exam with the subject you want to major in. I mean, obviously I have a degree. I have 2 degrees in physics now, and I didn't pass the AP Physics exam. So, it's definitely not a big deal if you don't pass the AP Physics exam and you just take it in college, and, you reinforce the stuff you didn't know. So that's just my little story about Physics 1 there. Next up, we have college reading and composition. This was a writing requirement, and this course was at like 7 o'clock at night on Mondays and Wednesdays, which was kind of a drag because coming from high school, you don't really have experience with classes that late at night. And so trying to stay focused in a 7 p.m. class was a struggle for me. But I did it. I had a really interesting writing professor, and who I felt like was kind of frustrated a lot because I think a lot of students didn't really take the course that seriously. Maybe it was because they were either just not that interested, or it was late at night and people just couldn't hide their frustration late at night as well. But I felt kind of bad for that professor because I felt like people weren't giving him the kind of effort that he thought the course deserved. And I felt like I learned a lot. I felt like he helped me with my writing style a lot. And so, it was a good course overall, in my opinion. All right, now if we move on to spring semester of 2014, we can still see I was a mechanical engineering major. And first course here is this course that says The World at Home. This might sound weird, but this is a course known as Core, Core, in UC Merced. That is sort of like a class that is designed to help people who are undecided in terms of what to study in college. So it's a writing class, but they bring in lecturers from all the different departments at UC Merced who kind of talk about what they do and what their subject is all about. So we had like people from chemistry, people from econ, people from math, people from public health, people from writing, English, history, just all come in, give a talk about like what their specialty is, and we would then write about it and discuss it in our discussion sections. And people complained a lot because they thought if you already knew what you wanted to do, you really shouldn't be taking this course. And I mean, it was sort of a mixed bag for me. Sometimes I liked the lecturers, sometimes I didn't. I kind of already knew generally what I wanted to do. I think a lot of people, like in my other writing course, just really hated it, and it sort of made discussions kind of a drag because people just didn't really want to talk about it and just didn't want to put in effort on certain things. So, mixed bag, but, got an A- and moved on. Next up, we have vector calculus, which honestly was kind of a drag because I was sort of hyped up for it because my high school physics teacher always talked about vector calculus and how it was sort of this really mystifying subject to him, and it was fun, but it was also really hard. So I remember really wanting to do well in this class and wanting to have a fun time in this class because honestly, looking back, vector calculus is really fun. You use it all the time in physics, but the course itself that I took at UC Merced did not have a great instructor, and like they were kind of very timid. Their voice just wasn't projecting that loud, even though I was close to them in the room, and they wouldn't write very clearly on the board. So it just made it a very difficult learning experience. So not that fun at all, if I'm being honest. I remember that, like, you see the grade there, it says A, but I'm going to tell you, like, the final exam, I think I had like a 70 or maybe even less than a 70% on the final exam. I felt awful taking it, but I think it ended up being that the average of that final exam was like a 40%. So me getting like something like a 70 was like curved to an A. So, I think when people look at these grades, keep in mind that just because the letter grade might say A or A minus doesn't necessarily mean I was getting like 100% on these exams. Sometimes it's like I'm getting 70% on the exams, but everyone else is getting, well, not everyone else, but a lot of other people are getting closer to 50 or 40%. And so, that's just sort of the reality of it, right? So don't take these grades maybe too seriously. I mean, obviously, I felt like I worked really hard for these grades, but at the same time, don't think that A means 100% all the time. A could be, 65%, where the average is like 40%. So just be mindful of these things. So next up on this course is Honors Physics 2. And Honors Physics 2 is where you learn about electricity and magnetism for the first time. And the honors part was that I would be in a smaller class. So my class was maybe like 10, 11 people big, as opposed to the general Physics 2 class, which would be on the order of like hundreds of people. So the honors class was really fun. I liked it because I met the instructor that I liked the most at UC Merced, who was in the physics department. I would have them 4 times throughout UC Merced, and they were an amazing instructor. They made things really clear, especially in a class like electricity and magnetism, where it's, for those of you who had never seen it before, it can be really mystifying and confusing. And I think they did a really good job at teaching that subject to us. So, really good job in that course to that instructor. So next up, we have Introduction to Psychology. Again, this is one of these requirements that I had to fulfill. And psychology was interesting because I think psychology is interesting, learning about Freud and Pavlov and all these different theories they have. But the course was designed in a way that you would have 4 exams, I think 4 or 3 exams. And I remember the first one I had like totally thought I bombed. I thought I failed that exam flat out. Turns out I didn't. But if I wanted to get like at least an A- in this course, I would have to like average, I think something like an 89 or a 91 or something like that. Something pretty high up there that's hard to maintain over 3 exams to keep an A-. And I ended up doing it, but it was not easy. So much props to that psychology professor. He made it fairly challenging, but also fair. I think it was ultimately very fair. It was just a lot of information you had to know going into these exams. So that concludes the end of my freshman year in college. And now we're going to go into fall semester 2014, where I was still a mechanical engineering major. Now, I want to preface this semester with a bit of a story. And I know this is sort of going a little bit differently from what people might expect, but the summer in between my freshman and my sophomore year was a really bad summer for me personally. I was going through a lot of things. For example, I just got in my first car, and that car just like suffered through so many different problems. That would break down, check engine light would go on, and just would stress me out, right? Just if anyone's ever had like a car that acts up like this, how stressful it can be having to take it into the shop all the time. And another thing that made it really stressful was that I had a really, really bad breakup in the middle of the summer. And so I kind of came back to UC Merced that fall and was like, you know what, I'm back. Let's try and get the best grades possible. I'm just so hyped and ready to go because I just had a really bad summer and was just trying to look for some motivation to turn things around. And if you look at how that semester turned out, it turned out pretty good. I think I really did turn around my bad summer. So if we start with the first class, it's General Chemistry 1. And I'm actually amazed that I got an A+ in this class because in high school, even though I passed the AP exam in chemistry, I really did not like chemistry. I thought chemistry was terrifying, so confusing, just didn't make sense flat out. And I hated doing the labs. But in this course, the General Chemistry 1 course, I had a really good instructor. I had a really awesome lab partner, and I had a really awesome TA. Just 3 things that just combined at the right time to really help me gain an appreciation for chemistry that I really didn't have before. And so because of these 3 things, I was able to do very well in the course. Obviously, I had an A+, but I definitely found a new respect for chemistry that I never thought I would. And this was actually the only chemistry class I took in college. So awesome experience. Would take it again, honestly, and maybe even want to take general chemistry too, because if I could have had that instructor again, it probably would have been, would have won even more. So moving on, we have linear algebra and differential equations, 2 math branches that are deserving of their own courses, and they actually do get their own courses later on, as you'll see. But these 2 courses are super important for any physics major, and at UC Merced, they combined them into this one course. And for those of you who are not aware, differential equations is the branch of math that focuses on solving equations that have unknown functions, but also derivatives of these unknown functions. So it involves calculus. And then linear algebra sort of is a branch of math that sort of generalizes the techniques of algebra that you might learn in, middle school or high school, but it sort of puts them in a more useful and more general context and just generalizes sort of the algebra we learn sort of on the two-dimensional Cartesian plane to an n-dimensional, space. So both really helpful concepts. I think in this course, though, I think I had an instructor. Yeah, I definitely had an instructor that wasn't the clearest, and again, didn't write the neatest. So it was kind of hard to make sense of what was going on at all times. But nonetheless, persevered. Tried my best in discussion sections with the TAs. Tried to study really hard for the exams, and it paid off. So really happy with that. Okay, so next up we have beginning MATLAB programming. So MATLAB was the very first coding language I ever learned. Some people might joke that it's not actually a coding language, and I can see where they're coming from, but it was really my first experience that had to do with anything with telling a computer, how to solve a problem, how to solve equations for me. And I took this course as a half semester course. So if you look at the credit hours, it says 2. So this is actually only a half semester course, which a full semester is like 16 weeks. So this was like an 8-week course, sorry. And, I think I was fortunate to have a very understanding and easygoing instructor because, it was terrifying at the onset because I thought, my goodness, like, how am I going to get through this? Because I don't know MATLAB at all. But from that experience, I learned how to code essentially, and that has, built and developed over time. And now I use mainly Python, not MATLAB, but I still have fond memories using MATLAB because I used it a lot in undergrad, as you'll see later on in the video. So next up we have Introductory Physics 3, and this course was taught by the same person who taught me Honors Physics 2, and Introductory Physics 3 is where we cover introductions to like special relativity, statistical mechanics, quantum mechanics, and we also have a lab component. So this was a very challenging course because it's such new physics coming at you. It's pretty much all the physics post 1900, effectively, when sort of quantum mechanics and special relativity first came about. And the lab course is brutal. It was like 6 hours long. I kid you not. I hit the microphone. 6 hours long. 6 hours. Wasn't making the right hand motions, but 6 hours long. I remember it was like from 1:30 to like 7:30 at night. And I remember when seeing that on the course registration, I thought to myself, you gotta be kidding me. This has gotta be like a typo or something. Ended up talking to the professor. They're like, nope, it's a 6-hour lab. And my goodness, those labs were brutal, absolutely brutal, because the labs were complicated. Like the equipment was not something you would just use on a day-to-day basis. You really had to sort of like read the lab manuals before you're going in there and sort of know what you're going to do beforehand. And you would run into difficulties all the time. Like things wouldn't work. You wouldn't get the results you would be expecting, and you'd have to troubleshoot. And man, I have bad memories from that lab, if I'm being honest. But nonetheless, I made it out of that class okay. And it was really cool to learn these new post-1900 physics ideas. So next up is a course called Intersections, which is a writing course. And for those of you who may not know this about me, I was actually a writing minor for a year, I think. Or a year, or maybe a bit less than a year. But essentially, I wanted to do a physics major with a writing minor. And I wanted to do this because I really thought writing is important in science, and it is. And I also had someone in my family, my grandfather, who was a really good writer. He was a journalist for a long time and then ended up writing for a newspaper on the side late until, after he retired, essentially. And so I always had this affinity towards writing, and I really liked to write, especially in high school. So I thought maybe I could combine, STEM with some, humanities part, essentially. And I really liked this class, actually, because the instructor, again, I had really great instructors at UC Merced, was really interesting, really entertaining, really just was real, really was real. Great descriptor right there. But nonetheless, was very helpful to me in developing my writing style even more. And this intersections was supposed to be intersections between creative and professional writing. I was going to be on a professional track because I was going to go into academia essentially. And so, I ended up realizing in this course, I think it was this course where I was getting bored at times, and I would be putting math equations and solving math problems in my boredom in my notebook during this course. So that ended up being the reason why I switched into applied math as my minor, because even though I liked writing a lot, I would still get bored and find time to do math instead. So that's why I switched into a math minor. But I still have fond memories from this class, definitely, no doubt. Okay, so next up, we finally have our first semester, spring semester 2015, where I am a physics major. All right, so what did I do in my first official semester as a physics major? First up, we have probability and statistics, and this is the last math course that you're required to take at UC Merced as a STEM major, unless you are a math major, of course. And so all the math that you have seen so far, this is the last math requirement you had to take for my catalog year. So they may have changed the requirements since then, but for my particular year, this would have been the last required math course I needed to take as a physics major. Probability and stats has always been very hard for me, never came to me intuitively, and I think this class really helped me become more comfortable with some of these ideas. But this was really my only exposure to probability and stats in college, and has been my only exposure since then. So it's still a muscle that I need to actively retrain and flex, because the ideas of probability and stats aren't intuitive to me still. I still have to spend a lot of time thinking about why certain things happen, or why certain formulas are the way they are. And I did have a good instructor for this class, as I've had in the past, but nonetheless difficult, especially the statistics part. The statistics part was really weird. I had never realized how difficult statistics could be. Those of you who do stats, and actually one of my roommates here is has a stats master's degree and is doing a PhD in econ, but uses a lot of stats. And my goodness, the level of stats that goes on at the really top level, it's mind-boggling to me, really mind-boggling. So confusing class. I'm glad I got out with an A-, but let's go ahead and move on to the next one here. So the next course we have is Analytic Mechanics Core, and this is my first physics upper division course. And analytic mechanics essentially is a step up, or where before in the introductory physics 1 course, where you learn about Newtonian mechanics, essentially, where you learn about F equals ma. You learn in analytic mechanics, or in the broader term, I guess the most common term would be classical mechanics. In this sense, you're learning about the different formalisms of classical mechanics that follow Newton. So you're learning about the Lagrangian formalism made by, I think his name was Joseph Louis Lagrange, and the Hamiltonian formalism, which was developed by William Hamilton, I believe. So these are sort of equivalent formalisms to Newtonian mechanics, but are more useful in different scenarios. And so you learn about them, and they're very differential equation heavy, and also even linear algebra heavy at times. So definitely was one of the first courses where you have to start using more of the advanced mathematics that you've learned in the math courses and put them to use. So I remember when I was learning about Lagrangians, I remember sort of zoning out for a couple of weeks for some reason. I think it was just super new, that it was over my head, and I just didn't know what I was doing. I felt like it was a dream when I was in class a lot of the time. I remember looking in my notebook years later and looking what was I doing between these couple of weeks? I don't know where my brain was, if I'm being honest. But yeah, that was my first upper division physics class. Okay, next up we have our Waves Minicourse. So this was an 8-week mini course, again, half semester course at UC Merced. And this course was weirdly, how do I say? I want to say contradictory, because the homeworks were pretty easy, really easy, I think. But then the exams would be really hard, at least to me. And I remember often be problems where I would just have like no idea what to do. Like I would study all the stuff we had covered, and then we'd get to a problem on the tests, and I was like, I don't know what to do. I have no idea what to do. So yeah, those tests I didn't do the best on, which is probably why I ended up with a B plus. But you know, I learned a lot. Waves are ubiquitous in physics. You have to really know your stuff. And waves can't. Let's just say you can't ignore waves. Waves are everywhere in physics. Let's just leave it at that. Okay, next up we have another half semester course, which was special relativity. This is, of course, Einstein's great theory of 1905, where he realized that people in, you know, movement between observers will lead to different observations. And this again was a half semester course. And this one was taught by an instructor who had a really thick accent and made it really hard for me to understand what they were saying a lot of the time. But they were very nice. They were very clear on the assignments and the tests. But the actual lecture component of this class was a little bit hard to get through, because just trying to listen and trying to understand, you know, very technically, you know, conceptually challenging concept from somebody who has a hard time expressing those ideas in English is not easy, right? You're sort of trying to like decipher what they're saying, and then you have to sort of like reprocess it in your own brain, trying to explain it to yourself. So that's what made it a little bit hard. But overall, really fun to learn about you know, relativity for the first time. Okay, next up we have science writing in natural sciences. So this is the required upper division writing course that everyone in the School of Natural Sciences at UC Merced needs to take. And it was a very useful class for me. They went over different kinds of, you know, writing documents that you might produce, like from writing grant proposals, from writing personal statements, from writing literature reviews in academia. All these things were covered in this course, and overall I really loved it. I think I had a great instructor. The funny thing was that I was like the only physics major in a whole class of mostly like bio majors. So I remember there was like this one point in the class where people were all going around saying like, you know, I'm studying this and I'm interested in this. And I remember there was like a string of people where they're like, yeah, I study biology and I really want to focus on like, you know, thinking about solving cancer and, you know, thinking of treatments. And this kept going on for like, I don't know, 5 or 6 students until he comes up to me. And then I'm like, hi, I'm Kyle. I'm a physics major and I like gravitational waves or something like that. So I made gravitational waves my topic for that like entire semester. So I wrote about gravitational waves quite a bit. And this was before the LIGO experiment was confirmed and, you know, confirming the gravitational wave discovery in 2016. So I took this course a year before the LIGO gravitational waves were found. And so that was kind of fun when they actually were found. And I was like, everyone in my course, I told you so. They would be found one day. So that was a cool moment, I'd say. And with that, we are now officially done with my sophomore year. Okay, now we're going to enter the beginning of my junior year in fall semester 2015. And we can see that the first course listed here is Thermal Physics Core. Now, thermal physics is a course at UC Merced that uses what's the book called? An Introduction to Thermal Physics by Daniel Schroeder, I think is the name of the book. And this sort of combines the ideas of thermodynamics and the laws of thermodynamics, applies it to systems like refrigerators, heat engines, and, you know, all these different kinds of apparatuses where you look at the transfer of energy between like a system and its environment. And I remember that the person who taught this course literally would draw every diagram that was in the book, every equation that was in the book, and that if you had the book in front of you, you would just see where he was pulling his quotes from. And he had the book in his hand, so he'd be like lecturing with a book. I don't have the actual book, but he'd be like having the book in his hand like this, and then he would be like just writing on the board. And then if you had the book in front of you, you'd be like, oh yes, you know, you're doing that. And then he'd ask questions like, oh, like what happens here? And then you would be like, oh, you just, you know, take the derivative and then you set it equal to 0 or whatever. And he'd be like, oh, good, you're paying attention. And it's like, I don't know if I'm really paying attention to maybe your derivation. I'm just paying attention to the book. But maybe they're the same thing. I don't know. But yeah, this is the only course actually that I saw statistical mechanics in besides my introductory physics 3 class. There was a separate statistical mechanics course that is usually a staple of physics degrees. Usually you have a standalone statistical mechanics course, but I think at the time for the physics major at UC Merced, because it was still so new, I think this was this satisfied your, I guess, statistical mechanics requirement. And I did see statistical mechanics in the course. It was not the whole course. It was like maybe the last 2 or 3 weeks of the course, but nonetheless there was discussion of statistical mechanics and partition functions and Boltzmann constants, all that good stuff you see in statistical mechanics. Next up, we have not even arguably, this is the hardest course. The hardest course I have ever taken at UC Merced, and that is electrodynamics. So electrodynamics is essentially the introductory physics 2 course, but on steroids. It is Maxwell's equations, but not watered down. It is Maxwell's equations in their full differential form. You're going to be using them to solve problems in electrodynamics that if you don't have the vector calculus and the different math skills necessary, it's going to be painful. And it was painful. That course was hard. There is no doubt about it. Like that course, oh my gosh, I remember just dreading every week, because the homework assignments were long. He would pull problems from out of Griffith's Electrodynamics, which is the classic book you'd use in that class, but then he'd also make his own problems. And man, some of the problems he would make, I was just like, oh my gosh, how am I going to solve these problems? They're too hard. Yeah, that was my experience. I remember the midterms also. The midterms and the final, just, oh my gosh. Again, this is one of those cases where you'll see my grade, it says A-, but it's not like A- and I got like a 91. It was like A-, but I got like maybe in the low to mid 70s. So this just goes to show how hard some of these courses are. And, it's not to say that you don't put in a lot of work and you don't learn a lot and that you don't deserve your grade, but it's like your idea of a grading rubric has to adjust in these courses, because it's not like in middle school where like A was defined to be like 94 to 100%, and then A- is like 90 to 93, and then B+ is like 89 to 87 or whatever, right? Like it's really subjective and really dependent on how you do relative to your entire class. So next up on the list, I would say, is probably a contender for maybe second place of hardest course I ever took at UC Merced, and that is quantum mechanics. I don't think that comes as any surprise to a lot of people. Quantum mechanics is conceptually challenging and mathematically challenging. I had a really good instructor. This was the same person who taught me Introductory Physics 3 and Honor Introductory Physics 2. And so this is like the third time I had them. And again, they're a wonderful teacher. Learned a lot from them. And they gave, they're not the easiest teacher in the world. I'm saying they're good, but that doesn't mean they're easy. They gave, long problem sets, and the midterms were a balance of conceptual and mathematical, which I like. That's sort of their style. But, quantum mechanics, undoubtedly really hard, really conceptually challenging. There's a lot of, lore and myth about it from people who maybe don't know too much about it. But it definitely wasn't what I expected, because when you think of quantum mechanics, I don't know. I mean, when I first heard of quantum mechanics in a popular science context, it was always like, spooky action at a distance, and Einstein hating it, and getting into it with Niels Bohr over things in quantum mechanics. So definitely sort of reshaped what I thought about it, but still leaves you with a lot of questions afterwards, which it should, because it still leaves a lot of physicists stumped to this day. Okay, so next up we have another writing course, and that was Rhetorical Theory. So I don't think I was a writing minor any longer, but I still needed to have some sort of, I think, social sciences or humanities requirement, and this fulfilled it. And it was going to be taught by the same person who taught me the intersections in writing course that I really liked. But to be honest, I don't really remember too much about this course. I just remember being kind of annoyed because I had a roommate at the time who I lived with who was also in this course, and they would do this annoying thing where they would like never prepare their assignments, well in advance, and then like come deadline date, they'd be bugging me when I'm almost already done and ready to submit, and they'd sort of be like, bugging me to like get their idea started when they had all this time to work on it, and it's like last minute they want me to like pull them out of this hole, and I was just like, I don't want to do it. So that's sort of what I remember from that course, as opposed to just learning about rhetoric and different kinds of rhetoric and thinking and discussing rhetoric in this course. It's weird. I remember we had a whole discussion what rhetoric even was, or is this rhetoric, and stuff like that. So, you know, times have made me forget a lot of things. Next up, we're going to move to spring semester 2016, and the first course listed here is complex variables and analysis. Well, actually, it doesn't say analysis, it just says complex variables, but there was some analysis in there too. This is actually my favorite undergraduate math course by far. I loved complex variables and analysis because it's just really fun, man. It's just really cool. It makes you not fear the imaginary number I anymore, square root of -1. And you really sort of learn the wonderful world of complex numbers and what you can do with them and how they're used in different contexts. Like, complex numbers show up all the time in physics. I mean, quantum mechanics is, in a complex vector space. So, you need to know about complex numbers. And this course had a wonderful teacher, super fascinating. I would go to their office hours like every time. We would just talk about math and other stuff. And they actually even lent me a book on like group theory or something, or it was some sort of pure math book that it's called Abstract Algebra. That was it. It was the book Abstract Algebra. That's what they gave me. So just wonderful course. Had a great time, and just really wanted to do well in that class overall, and I think that's why I got the grade that I did. So good job, instructor. Okay, next up we have electromagnetic radiation, which is just a continuation of electrodynamics. So this is sort of applying Maxwell's equations, but we're going to apply it to radiation and the motion of waves, electromagnetic waves. And so this was, I think, also a half semester course taught by the same person who did the waves mini course. And I remember in this course I had to buy this like really old book. I think it's Bekeffi and Barrett are the authors, and I think it's like electromagnetic waves, radiation, and oscillations, something like that. But I just remember that course being really, really hard. It was hard. That's for sure. It was really hard. But we were allowed to use our book on the final, I think, if I'm not mistaken, which is probably why I did really well on the final. But yeah, really hard course. Can't deny it. Okay, next up we have Atomic Structure mini course. So this is sort of like a follow-up to the quantum mechanics course that I had the previous semester. And this is where we're now applying quantum mechanics, but now we're looking at atoms and even molecules even. And how we learned that once you get past sort of the hydrogen atom, you really can't solve the Schrodinger equation anymore exactly, and you have to rely on approximation methods. So tough class. It was taught by the same instructor who taught special relativity for me, and had a bit of a thick accent and hard to decipher words. So that was sort of a difficulty one more time. But again, they were a very nice person. They were very clear in their instructions on the homework and the exams. Just the lecture part was kind of hard to follow. But overall, good course. Learned a lot. And moving on, we have Modern Physics Lab. So this is, again, another one of those 6-hour labs that I've mentioned before. And my goodness, 6-hour labs are brutal, man. Like, they just eat up your entire day. It's like you could have nothing else in your day, and then you have a 6-hour lab, and it's the worst day ever. I remember for the other one, not this one, but for the other one, I remember I had a choice between having a course either right after my 6-hour lab or like 9 a.m. the day after my 6-hour lab. I chose the 9 a.m. option, but could you imagine taking another course after a 6-hour lab? That sounds like hell. I'd never want to do that. But so the Modern Physics Lab was interesting. It was literally just us in lab every week, and we would be doing a different experiment every like other 2 weeks. So we'd have like 2 weeks to try and complete a whole lab experiment. So the different lab experiments that were out there were like, I think there was like a double slit experiment one. There was like another optics one. There was a sonoluminescence one where you're essentially trying to create light from like a trapped bubble, essentially, which is really cool. There was one where we tried to learn how to use the program known as LabVIEW, which is a software where you can use, you can pretty much like design virtual experiments and virtual laboratories. It's kind of weird, but like maybe I'll show you a schematic, but it's sort of like where you design these things, and then if you hook up equipment to this this thing they call a DAC, it could control different apparatuses from the computer program you wrote. So very cool stuff. Very cool stuff. Okay, now time to get to the final countdown. Let's get to the final year in college. So fall semester 2016. I think at this point I actually had finished most of my physics requirements outside of like my required bachelor's thesis. So I think this entire year, my senior year, was essentially spent on trying to finish up my math minor. So first up, we have intermediate differential equations. This is just a extension of the differential equations and linear algebra course I had before, but just solely focusing on the differential equations. So we're learning about, like, you know, again, differential equations using like methods such as variation of parameters, like method of Frobenius. We could also get into sort of like Sturm-Liouville problems and stuff of that nature. I know this is very technical stuff, but again, being a physics major and a graduate student, you really need to know differential equations cold, and so knowing all the different techniques was definitely extremely useful for me to know. Next up, we have numerical analysis, and numerical analysis kind of had a bad rap at UC Merced because it was mainly an engineering course that I think the year that I took it, they finally made a math version of this course where it was taught by someone in the math department. And numerical analysis is simply where you are trying to essentially like optimize, or like it's like optimization, or trying to find the roots of some equation. By roots I mean trying to find the zeros of an equation, and using algorithms that have been refined over the years, so computers can do these sort of calculations. And the math version of the course, which is the one that I took, was interesting because you learn more about the theory, I think, than you would normally learn in the engineering course, but you'd still do a lot of problems in MATLAB. So we were using MATLAB to take these problems and solve them, essentially. So apply these algorithms that we learned in class, like Newton's method or the secant method, or the shooting method, all these different kinds of methods. Learn about like Chebyshev and Legendre polynomials, Fourier series, doing expansions, series expansions, and approximating functions with series expansions was also a main part of this course as well. So that was pretty interesting stuff that I still do numerical analysis in my own research today. So this class was definitely a good one to take for me. Next up, we have linear analysis 1, which, like the intermediate differential equations course, this is an extension of linear algebra now from the linear algebra and differential equations course that I had my sophomore year. And here was this was a very mathematically rigorous course where we're sort of defining things from first principles, and really thinking about what makes a matrix singular, or what does it mean to find the eigenvalues and the eigenvectors of a matrix, and what does that mean graphically and physically. And linear algebra, like I said, is super important in physics. It's the backbone of quantum mechanics, so you kind of really need to know this stuff. And I definitely learned a lot and definitely thought about linear algebra in a different way after taking this course. So much props to that instructor for enlightening me about linear algebra. The one thing I will say though is I wish we kind of went at a bit of a faster pace, because we didn't end up getting to the parts of linear algebra that would have been important for quantum mechanics. So for example, we didn't get to like Hermitian matrices in linear algebra, and a Hermitian matrix is something that you see a lot in quantum mechanics. So the fact we didn't get to it made me a little bit sad, but overall very good course nonetheless. All right, here we go. The last semester, the final countdown of college, spring semester 2017. So first up, we have partial differential equations, which is, as opposed to ordinary differential equations where you have a function of one variable and its derivatives in an equation, you have a function of multiple variables now that you're trying to solve for in these equations. And the thing that I mainly remember from this course is that we did separation of variables a lot, which is essentially like but one of your primary methods of attack when solving a partial differential equation. And we learned a little bit about like eigenfunction expansion and we got to, I think, Green's functions a little bit as well. And we covered, many different kinds of differential equations. We covered like the heat equation, the wave equation, Laplace's equation. So again, super important when you do physics. Partial differential equations are everywhere in physics. So yeah, definitely needed to know that. And again, I had a really great instructor. This was the same instructor, I think, who taught me numerical analysis. So we, I think we got along well, and that they had a teaching style that I could vibe with. Okay, next up we have mathematical modeling, which was a really fun course. This was where we used MATLAB again, but we were given different sort of projects where we would try and model different phenomena, and we learn about sort of the theory of mathematical modeling and how mathematical models are used and designed to help make predictions. And some of the projects we would do, one of them was where we would make a simulation where we would essentially try to model the traffic at a stoplight or a stop sign. And we could see that, like, if there was a probability of like a new car coming, a certain amount of the time, and then, you deduce the number after the car leaves goes through the intersection, you could see sort of the rise in, traffic over time. And so that was kind of fun. Another project I remember doing was we sort of did a double pendulum project where the two pendula are sort of like attached to each other. And then we put the double pendulum on a different planet. I think we used Mars as the example. But it was really cool because these pendulums are really subject to the gravitational force on them. And if you change the gravitational force, then the motions that they undergo are going to be different. So putting them on a different planet as opposed to Earth, like Mars, was just kind of a fun little thing we could try and see what happens. So that's what we did there. And last but not least, here we go. The last course on the list is computer-aided engineering. Now, this was a course that I needed to take to fulfill some sort of requirement. I can't remember what, but I needed to do some other, I think I needed to do some non-physics science or STEM requirement. And this was like the only thing that could fit in my schedule. And I was kind of scared to take this because obviously I had switched out of mechanical engineering, and I didn't think I would be doing anything with engineering again. This course is where we would use the program known as SolidWorks, and we would use it to design different things. So I remember having to be tasked with like designing like a wrench and like a few nuts and bolts that, in all of SolidWorks, you can sort of design these things and you can print them via a 3D printer if you give them the blueprint. So we're essentially just like blueprinting these things and, giving them certain dimensions and different sizes and learning how to use the program to design these things. I remember at the very end, we had to do like a final group project, which was worth a big portion of the grade. And I think the thing we designed did not get printed out that well at all. And I think we got a bad grade on the final, which is probably what brought my grade down to a B. At this point, I was ready to graduate. I knew I was going to graduate school at this point, and I was just ready to get out and graduate. So I didn't really care too much at that point. So yeah, that is it. We reviewed all the courses I took in a classroom setting in undergrad. Wow, that was long. This is going to be a very long video, I can already tell. But I hope that gave you some idea as to what a physics degree could look like at your university. Obviously, a lot of these things that I've shown were very specific to myself, but there are some things that are completely unavoidable as a physics major, and hopefully I made it a point that there are certain courses that you just cannot avoid as a physics major, and you definitely should know when you're going through that degree. So again, I hope you enjoyed this. My voice is really tired from talking for, I guess, over 40 minutes now. My goodness. And I hope you learned something new, and I hope this helped you out if you are curious about the physics major, and hopefully it enlightened you about, what actually a physics major does in college. And it's not all about black holes and, string theory and all that good stuff. But yeah, that's pretty much the end of the video. So thanks for watching, guys. I'm going to try and get some water to refresh my voice, and I will see you guys another time. See ya.